Hello everyone, it's Benny, and welcome to part 5. Last time, we added this bit shifting hardware to our ALU. So now, we can shift left or right with our ALU. So now, in this part, all we have left to do are essentially the finishing touches. We're going to add the remaining arithmetic and logical functions, and we're going to add an accumulator to this ALU. So, let's go ahead and let's get started. So, the first thing we're going to do is build the accumulator. And all the accumulator is it's a piece of memory that remembers the ALU output and then buses that directly back into one of the inputs. And the reason you'll want that is because the ALU is the primary unit of computation for the whole computer. So if you can take advantage of the accumulator and just keep busing the ALU output right back to the input really quickly like that, it lets you do some more advanced calculations very quickly because the input's just going through and again and again and again really, really fast. So it's a cool little trick. So to build this, the first thing we're going to need to do really is bus this output back to the input. And you might notice that busing is going to be a little awkward because we have to build the memory cell somewhere in this space and then bus it all the way around our OR gate logic and then back into the input. That's a little bit cramped and it's a little bit awkward. Wouldn't it be a lot easier if we could do our accumulator busing over here, where we have this big empty space and the flood carry logic, which is not nearly as bulky and much easier to bus around. So that's the first thing we're going to do. We're going to build a second output for our ALU just for the accumulator, just so that it's that much easier to bus it around into one of the inputs. As the added benefit of leaving this space open so we can bus this out to the rest of our hardware whenever we build that. And we won't have to worry about interfering with the accumulator or anything. So let's go ahead and let's do that. So, if you remember, there are two parts to our output. One is going through the torches like this, and this part should have no trouble bussing around. You see, it just goes around the wire, there it is at the output. But the other part will. That is the carry that can sometimes go through this comparator. And if it does that, the signal strength here can sometimes be as weak as 1. And that's not going to reach all the way around this bus. So we're going to need to essentially do this again on the other side of this ALU. And that means we somehow need to get this XOR over here. Fortunately, there's a little bit of a sneaky trick we can do to achieve that. If you see right here, this wire is also the XOR. See, it's just before the repeater. So I can bus it through here, just like that. And now we have the XOR on the other side. So I can put a block here, half slab down a bit. I can't put any more wiring here. And the reason I need a half slab is so this will tile like this. See? And like I said, I can't put anything else there, so I'm going to put a block. Just going through the block into a repeater, and you'll notice this happens to align pretty nicely with our little dot of carry. So the carry is going to power this block, which is going to go to this comparator, and just like that, we have the same comparator logic on both sides. I can just put it right here, and there you go. Just like that, with minimal additions to the ALU, we now have 2 outputs. And that is really awesome. So I'm going to go... Let's see, how would I stack this? Well, on the most basic level, I can go position 1 and position 2. I can expand 2 this way. I can put blocks down here, and I'm going to put redstone there, so the redstone will tile. I can expand 1 down, and I think this should work. Awesome, it appears to be working. I do need to have the blocks all the way through, but that shouldn't be a problem. I can actually just even do that by hand. So I'm placing all the blocks. So the carry is now powering the comparator. And yeah, I just finished this up by hand. This is not a lot of work at all. And there you go. So now that we have two outputs, and no power up torch, this is going to make, well, doing the accumulator and the busing so much easier. Okay, I'm back from the future, and I just realized that I forgot to stack this part all the way down. So I'm going to show you me doing this now. Just ignore the extra stuff I built. So this is position 1, and this is position 2. I'm going to expand one down. And just like that, I should be able to stack 7 down. And now we have all of those in place. I can break that block because we don't need it. So cool. So, the way we're going to do this, the way we're going to bust the accumulator, is we're going to go through a repeater lock. And actually I can go through an extra block right there, just to make it go a little bit farther. And yes, there's not really a lot of space there to do the repeater lock, so I'm going to do it on the other side. I'm going to do the repeater lock right here. I'm going to bust down this way. Whoops. Just like this. And yeah, this is going to be the memory for the accumulator. And I can, go here, position 1, position 2, expand 1 down, stack 7 down. Excellent. Now we have an accumulator. Or at least most of one. It's not bust back to the input just yet, but that should be okay. And this should have some leftover signal strength, shouldn't it? Yes. Okay, good. That means I can power it from... Oh, I'll just put it here. It doesn't really matter yet. So I'm just gonna have this... There we go. So cool. Now we have this wire. All we need now is some way to bust this around the flood carry and back to the input. Alright, so let's bust this around. I'm going to go here. I'm going to go around the, well, the flood carry control wire. And I'm going to go here. I'm going to put a half slab here so that I can go up one. I don't need this just yet, but you'll see in just a moment. Because what I'm going to do here is rather than bust this directly into the output here, I'm going to implement a little bit of control logic. And that way, well, it'll give me more options. Instead of just being able to send the input in directly, I can send in a few other things. Most notably, I'll probably want to be able to send the inverse of it. So, here is the input directly. I'm going to do it with a comparator so that later on I can have something like this, a repeater and a slab tower. Going just like this. The other thing I want is the NOT gate, so I'm going to go up one like this so that it can do a side of a comparator and a comparator NOT gate. I can just do a block here so that it reaches. So, see how that works? I just need to power it with something. Now here's where you'll need some furnace or hopper logic. I'm again going with furnace. I've already got out the furnace that's power 7. So you need 7 signal strength coming out of this. And you'll notice this happens to have already bust all the way through the ALU and back around. If I break this, the NOT power, see, no change in signal strength. So signal strength exactly the same, regardless of whether it's coming from, well, whichever input it's coming from. So yeah, and it's just barely enough to reach everything. So this is perfect. Hello, it's Future Benny again, with another minor correction. This furnace should have a signal strength output of 8, not 7. That's true of every furnace all the way down the line. The reason is, otherwise this isn't quite strong enough to reach this block right here. So just be mindful of that. If you don't have this as 8, you're going to get some weird results. And there, so the only other thing is, like before, I'm going to want some way to disable this if I don't want the inverse of the input constantly flooding through. So I'm going to put a block here into my slab tower over this way. This, whoops. Yeah, that'll allow me to bust like that. I'm going to put a half slab here for tiling purposes. I'm going to set this as one of the positions. I'm going to set this. Would this be the right place to do it? I think so. This is another position. I think I am going to have to do something like this, though. Otherwise, I don't think it'll tile properly. And is there anything else I have to do to make it tile? I have to put that there, I think. Let's just stack one down and see what happens. So, okay, clearly that did not work. Okay, so I need that there for that to tile properly. Let's stack one down. And, yeah, that appears to have worked, I think. Okay, let's stack 7 down. Cool. Now we have 2 control wires that can allow us to do various very basic operations on the input before it goes into the rest of the ALU. So, yeah. But first I need this, so let's power that. And cool, now our output is all on. Okay, so for this, first thing I'm going to do is torch and solid block. This way, this will disable the ordinary output, and now, for some reason, it's causing a loop of flashing, but that's okay, it's going to be fixed in just a moment. Oh, this is important. Excuse me. Here I'm going to have another solid block, and I'm going to put a torch here. So, there. This should be allowing nothing through, and I can now break these, because I do not need them. That was just for tile. It's cool if I send power through here. And that also explains why this was the only thing that was flashing. It's the only bus that actually goes all the way back through. Okay, so I'm going to set this to position 1, and over here to position 2. Expand 1 down, and stack 7 down. So cool. We now have a bus that takes the accumulator, takes the output, it can go through the accumulator, and back to the input. Just like that. And we can do some basic control logic here. For example, if I'm going to need to label these, and that might be... Hang on a second. You see, the tiling wasn't quite complete because this one doesn't quite bus all the way back down. And in fact, let me check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there wasn't any weirdness where I somehow ended up with an extra wire. It's just, it didn't quite reach far enough down. Which is okay. That's fixable. So we need the comparator here, repeater here, and the solid blocks here. And this is where the torch is going to go. Actually, that's perfect, because that gives me the other torch right here. And now I can, just add a block above labeling. So this will allow A through, and this will allow not A, the inverse of it. So if I flip this, now it's just a giant flashing 8-bit gate that isn't quite reaching the top for some reason. This block. Broke this block. So, let me just turn this off. This is a little bit laggy, running through at maximum flash like that. And put a block here. There. And actually, even better, let me power this so the accumulator doesn't keep coming through constantly, just an infinite loop. So there. Now we have not A going through. If I allow A through, this is cool because no matter what I have as A, this will always be all 1s. Just like if I have both off, it will always be all 0. Oh, apparently the server lagged a bit. That's okay. So this is cool. We can now have a nice way of doing inputs, well, for the computer. But we're going to want the same sort of control logic for the other input, even though it's not coming from the accumulator. So I'm going to do some fancy copy and pasting sorcery. So this is going to be position 1, and if I fly down here, this is going to be position 2. And I go over here, and I copy. And we're going to have to flip this, kind of like before. So I'm going to go here, and flip, facing this direction. And now, if I do a test paste, cool, that appears to have worked. So I can go right here, and, paste. And just like that, we now pretty much have the control logic done for the computer, though I don't think we're going to need any sideways busing like that. And there you go, we have one input over there, and the other input is the accumulator, and that's the output. Hello, it's Future Benny with one final correction. When you paste over here, make sure to change all the furnaces to signal strength 9, not 8, 9. And that's true, again, of every furnace in the row. The reason is, it has to reach this torch over here, which happens to be, you can count them up, exactly 9 blocks away. And yeah, once again, it's really important to get this right, because if the signal strength doesn't quite reach everything, you're going to get a lot of really weird and hard to find problems. So just be mindful of that. Again. Now, one final minor feature we can have is vectorization. Now, right now, I am adding 5 plus 12, which is correctly telling me it's 17. But what if I don't want this to be acting like an 8-bit adder? What if I'd rather have it acting like 2 4-bit adders? And that way I can do 2 4-bit additions at once. So this is something kind of cool you can do. And the way this works is what I'm going to do is I'm going to go up here. This is bit 1, 2, 3, 4. I'm going to put a repeater powering this block, a repeater powering that block, and this is going to be our vectorization command. The way this works is actually pretty simple if I can ever get in to show you. The line right here is our cancel line. So what this is doing is anytime the carry tries to go beyond 4 bits, it cancels it. But it doesn't stop carries from the bits beyond that from being generated or propagated. So it does exactly what we want. It essentially makes us act as 2 4-bit adders stacked on top of each other. And it's not something we'll probably be using a lot, but it's there, and it definitely has its uses. Okay, I have just finished testing the ALU and recording those corrections you've been seeing from Future Benny throughout this build. So hopefully your ALU should be problem-free if you've been following along and following all those corrections I've been giving. So cool, this is the finished ALU, folks. Well, the core functionality anyways. Strictly speaking, we're going to add a few minor things later, but that's not important right now. All the core behavior is here. So let's do some basic tests just to show you this ALU in action. And you don't have to do this, I'm just basically showing off what we've built here. So To do this, I added a block with a lever and all the inputs to the data. This is just to show it off. I haven't done it on camera because I'm going to break these after this testing recording is done. So yeah, I'm going to put in 5, and you notice I'm putting it in inverted. And I'm going to use our inverter to uninvert it and get the actual 5. So cool, we can do that. And now I'm going to save that to the accumulator. Now our default mode for the ALU is add. So if I put in an inverted 3, for example, I need to let the accumulator through, so let the accumulator through. There we go. 5 plus 3 is 8. Let's write that to the accumulator. So cool. Now, what should we do next? I know. Now I'm going to put in 7. Actually, no, that's not a good example. Let's put in 15. Sure. And I'd like to not add these together. I want to do something a little different. Let's flood carry these. So I'm going to put... I apparently broke my flood carry sign, but that's okay. So I'm going to turn on flood carry. And this should XNOR them. And I need the carry in. Almost forgot. And perfect. This is doing the inverted XOR of this. And if I invert one of these, if I invert the accumulator, for example, I'm now doing the XOR of them. So it's kind of neat how that works. So I'm going to go back to the normal accumulator. Actually, sure, why not? I will save this as a result. So cool, now we have the accumulator. I'm going to turn back that and that. So we've XOR'd them, and now I'm adding them again, but I don't want to do this. I want to turn this off. Now I want to test our bit shifting. So I'm going to disable normal output, right here, apparently. Okay, and let's shift left. So this should exactly do that. And now I should be able to just briefly write. Cool! Shifted left again. And shifted left again. Excellent. And if I want to do it the other way, what I can do is switch and do shift right. And, yeah. So I'm going to shift it back to where it was originally, just because I can. And I'm going to switch back to normal output mode. And why not? I'll show off the OR function as the grand finale. And I'm going to OR... yeah, let's OR 9. Why not? So allow not D, and there we go. It has all the bottom 4 bits on. So cool. That is our completed ALU. Thank you. Hope you enjoyed. I hope you learned. And next time, we'll start building the next big component of the computer that allow us to make this, well, a little bit more computery, rather than just sort of a universal function machine, I guess, for lack of a better term. So yeah, thank you. Hope you enjoyed. Hope you learned. And I'll see you next time.